Okay, so today we are going to look at molar mass and calculations using molar mass. So what is molar mass? You've had experience with molar mass with the periodic table. The masses on the periodic table, those are the molar masses of substances, of the elements. And it is the mass in grams of 1 mole, or 6.02 times 10 to the 23rd entities of a substance. And the symbol for molar mass is a capital M. Molar mass of an element is equal to the given mass on the periodic table. For example, the molar mass of neon would be 20.18 grams per mole, which is also the same as atomic mass. To find the molar mass of a compound, it is equal to the sum of the molar mass of each element in the compound. Don't forget that some language around molecules and atoms and so on is that molecules, an example would be carbon dioxide. They are made of atoms, and formula units are ionic compounds and are made of ions. So for example, sodium chloride. It's useful when you are doing the problems around molar mass and the mole to know that these definitions. So how do we find then the molar mass of some substances? So take a look at finding the molar mass of sodium chloride. To find the molar mass of sodium chloride, we take the molar mass of sodium and add it to the molar mass of chlorine from the periodic table. And that would be equal to 22.99 grams per mole plus 35.45 grams per mole. And it equals 58.44 grams per mole. In this case here, the ratio of sodium to chlorine is 1:1. And what happens then if it is different? And there is a subscript, which indicates there are more atoms of that particular element in the molecule. So in the case of carbon dioxide, to find the molar mass of carbon dioxide, we take the molar mass of carbon and we add it to 2 times the molar mass of oxygen because of the little 2. So this little 2 here translates into the 2 in front. So it is equal to 12.01 grams per mole plus 2 times the molar mass of oxygen, which is 16.00 grams per mole. We multiply that through and then add them together to get 44.01 grams per mole. So those are some examples of finding the molar mass. We will see some further examples and some other examples later on. For more practice, you can try page 275, number 1. Okay, so let's now use the molar mass in calculations. So we use the molar mass to help us convert between mass in grams, and the symbol for mass is lowercase m, amount, and the unit for amount is the mole, and the symbol for that is lowercase n, and molar mass, and the unit for that is grams per mole, and the symbol for molar mass is capital M, as we've seen. So in order to convert between those, we use this formula. Moles, or the amount, is equal to the mass in grams divided by the molar mass in grams per mole. And we can put that in triangle form. Some of you like using a triangle to help you solve your problems. I suggest that you learn how to rearrange equations and do not simply use this as a crutch, but check your work with your triangle. But it's a quick way to do it. So, example 1, converting mass to amount. How many moles of sodium nitrate are in 1.70 grams of sodium nitrate? NaNO3, a substance used in fertilizers and to make gunpowder. So we will put this in problem-solving format, and this is what will be expected from you when you do your assignment on the mole. So make sure you follow the format that's given. So we are asked how many moles, so that's our lowercase n is equal to question mark. We are given the mass of 1.70 grams, and our substance is sodium nitrate. So we will need to find the molar mass of sodium nitrate. So here's some more practice of finding our molar mass. So the molar mass of sodium is 22.99 from the periodic table. So obviously you're going to need your periodic table handy when you solve these problems. The molar mass of nitrogen, there's one of them in the compound, is 14.01 grams per mole. And there are 3 oxygens. Oh, there's a little plus in the middle there. And 3 times the molar mass of oxygen, which is 16.00 grams per mole. Okay, multiply that through and add, and we get 85.00 grams per mole. We indicate 2 decimal places because all of the molar masses show 2 decimal places, so we will show them as well. Although this is not a measured value, but we'll still indicate the same amount of significant digits. Okay, so from there we're going to find our moles, which is equal to our mass over the molar mass. Which is equal to 1.70 grams divided by 85.00 grams per mole. And of course, grams will cancel out. And we are left with 2.00 times 10 to the negative 2 mole. Now your calculator will show this, right? 0.002. Why do I put 2.00? Well, the question indicates 1.70, so I go with what's in the question. The measured value in the question, how many digits does it have? The lowest amount, and we have 3 digits, so we indicate 3 digits, so we use scientific notation. So remember, when we're doing scientific notation, we move the decimal between to the right of the first non-zero number, and then we indicate times 10 to the how many times we move the decimal and which way. So because we went to the right, that meant that we have a negative number, and so we went 2 times to the right, 1, 2, so that indicates to the negative 2. Okay, and so from there we need a therefore statement. So therefore, there are 2.00 times 10 to the negative 2 mole of sodium nitrate in a 1.70 gram sample. Okay, moving on to another example. Same kind of question. We have example 2. A solution of zinc chloride, ZnCl2, in water is used to soak the ends of wooden fence posts to preserve them from rotting while they are stuck in the ground. How many moles of zinc chloride are there in 840 grams of zinc chloride? Okay, so let's read our question again, underline what was asked of us and what we are given. So how many moles? So that's our N again, N equals question mark. And our mass is 840 grams. Our substance is zinc chloride. So we know we need our molar mass. We need our molar mass, so let's find that. So our mass of zinc is equal to 65.41 grams per mole. And we have 2 chlorine, so 2 times 35.45 grams per mole. We don't necessarily need that there. Okay, and multiply and add, we get 136.31 grams per mole. So we can use that in our calculation to find our moles. So again, we're finding moles, so moles equal to mass over molar mass. We have 840 grams divided by 136.31 grams per mole. Cancel out the grams. And we get 6.16 mole. Again, how many digits do we use? Well, we had 3 in the question, so we have 3 in our answer. So therefore, there are 6.16 moles of zinc chloride in a 840 gram sample. Okay, so there's another example of that, and you can try some questions. You can try as many as you like. I'm going to suggest you try page 277, number 4 to 8. But you will be provided with the solutions to other ones that are there. Okay, so let's also now try another type of question where we are converting from mole, our amount, to mass. So amount, that's our N, and mass is obviously lowercase m. So to do that conversion, right, we have our triangle N, M, M. To use our triangle, remember, we hide what we want to find. So if we want to find mass, we hide it, and that means that we are taking lowercase n times molar mass. That's how that works. And if we want to find moles, we cover that, and that means we take lowercase m and divide it by uppercase M. Okay, so that's how we use our triangle, in case you forgot. So here's another question. Calculate the mass of 0.100 moles of sodium carbonate. So here's our substance, and how many moles we need, and we're finding the mass. So M is equal to our question mark, and N is equal to 0.100 moles, and our substance is sodium carbonate. So again, we'll need the molar mass of sodium carbonate, so Na2CO3, and that is equal to 2 times 22.99 grams per mole, plus 12.01 grams per mole, plus 3 times 16 grams per mole. And all that multiplies and adds to 105.99 grams per mole. So M is equal to N times capital M, which is equal to 0.100 moles times 105.99 grams per mole. Moles cancel out, and let's put that in our calculator. 0.1 times 105.99. So I get 10.599 in my calculator. How many digits will I keep? Question shows 3, so I will keep 3. So that's 1, 2, 3. So 1. I could make this 10.6 grams if I want. 10.6 grams. Or you can put it into scientific notation if you like that, to 1.06 times 10 to the 1 grams. So either answer is fine. Therefore, the mass of 0.100 mole of Na2CO3 is, I'll just stick it to 10.6 grams, okay? All right. And one more example where you can do some practice. Example 2 says, calculate the mass of a 0.500 mole sample of table sugar, C12H22O11. So calculate the mass. So M is equal to question mark. We have N is equal to 0.500 moles. And we need to find the molar mass of C12H22O11. So I'll just give you this one because we've done a few examples now. Hopefully you're good with that. So 342.34 grams per mole is our molar mass. And now we'll put it into the formula. So M is equal to N times capital M is equal to 0.500 moles times 342.34 grams per mole. Put in my calculator, 0.5 times 342.34, and I get 117.17. So how many digits will I keep? 1, 2, 3. That's the only number I have in the question, so I keep 3. So my mass would be 171 grams. So therefore, the mass of a 0.500 mole sample of C12H22011 is 171 grams. Okay, so you've got some practice on page 277 that you can do. Number 1 and 2 I suggest, and questions 4 to 8 should probably be sufficient in practice, but you're always welcome to do more. Okay, so happy problem solving, and reach out if you have any questions. Have a good day. Bye.